Next time you're driving on the highway, look closely at the semi-truck next to you. You might notice something strange, something that looks like a mistake. Some of the massive wheels aren't touching the ground. They are floating in the air, spinning uselessly or completely stopped. Is the truck broken? Did the driver forget to lower them? Or are they just spare tires attached in a weird place? Actually, none of the above. That floating wheel is an engineering masterpiece. It is the only reason that truck can legally drive on this road, and it saves the trucking company thousands of dollars a year. But how does it know when to touch the ground? And why do we lift them in the first place? Welcome to the hidden mechanics of the highway. Welcome to Logic Layer. The friction problem. To understand the floating wheel, we first have to understand the enemy of every vehicle, friction. Every tire that touches the asphalt creates rolling resistance. More tires mean more friction. More friction means the engine has to work harder, and a harder working engine burns more fuel. A standard 18-wheeler has, 18 wheels. If a truck is driving empty, say after dropping off a delivery, it doesn't need all those axles to support its weight. If all tires stayed on the ground when the truck was empty, it would be burning fuel for no reason. It would also wear out expensive tires unnecessarily. So, engineers created a solution, the lift axle. It's a simple logic. Use them when you need them, hide them when you don't. The mechanism, how it works. So, how does a heavy steel axle just lift into the air? It's not magic, it's pneumatics. These trucks are equipped with heavy-duty air suspension systems. When the driver flips a switch in the cab, or when an automated system detects a light load, giant rubber airbags inflate or deflate. To lift the axle, air is pumped into a lifting chamber that physically pulls the wheels up, away from the road surface. To drop the axle, that air is released, and different airbags push the wheels down with thousands of pounds of force. It transforms the truck's geometry in seconds, but saving tires isn't the only reason they exist. The real reason is the law. The bridge formula. Here is where the engineering meets the legal system. In the United States and Europe, there are strict laws about how much weight a vehicle can put on the road. But it's not just about the total weight, it's about weight distribution. If you put 40 tons on a single point, you will crack the asphalt and destroy bridges. This is defined by something called the Federal Bridge Gross Weight Formula. This mathematical formula dictates that the heavier the load, the more axles you need to spread that weight out. So, when a truck is fully loaded with heavy steel beams, it must lower those extra wheels to legally distribute the weight. If they don't, they get a massive fine at the next weigh station. But the moment that cargo is unloaded, those extra wheels become dead weight. So, up they go. The toll booth hack. There is one more hidden logic that drivers love. Toll roads. Most highway tolls charge by the axle. A 5-axle truck pays more than a 3-axle truck. By lifting 2 axles off the ground before approaching a toll booth, a driver effectively changes the classification of their vehicle. They physically transform their truck to pay a cheaper rate. Over a year of cross-country driving, this simple trick can save a logistics company thousands of dollars. So, the next time you see those phantom wheels hovering above the asphalt, remember, it's not broken, it's smart engineering. It is a dynamic system reacting to physics, economics, and the law, all at the same time. It saves fuel, it saves tires, it saves bridges, and yes, it saves money. The world is full of hidden mechanisms like this. You just have to know where to look. If you enjoyed seeing the logic behind the machine, hit that subscribe button. This is Logic Layer. Drive safe.